Okay, so a lot of you looks like have chosen to write the problem down. So then once you've done that, what is the question ultimately asking for? We're on tape, so be aware of that.
Oh,
Do I need to pause this? Or?
I probably won't swear. I need to steal
Okay.
the one that lives at the same house as me. Is she? Okay.
All right. So how many times have we possibly said the best thing that you can do is what is the next thing to do is the best thing you can do for yourself? Okay? So what do we know in this content? Okay? So 4.35, and most common use for time is what? Same thing here. We got 4.35 seconds. What else do we know in this problem?
The acceleration is 9.8 meters per second squared.
How do we know? I don't see 9.8 up there.
Gravity.
But due to gravity, which has a specific value, that remember, if we're talking about this vertical sense, okay, chances are you're using 9.8 because that's the acceleration due to gravity. But if it's in the horizontal motion like this, if you don't use 9.8, that probably means you need to calculate the acceleration. Okay, so you correctly said acceleration equals 9.8 meters per second what? And please keep that distinction in mind because we do not want you to put an acceleration in where a velocity belongs. What else do we know in this problem?
The mass is 2.85.
Okay. And if we're not careful, do we see that number up there more than once? Yes, actually right here. Okay. So what is the 2.85 measured in? Okay, just like what we see here. Okay, do we know anything else in this problem? Now, if we read that a little closer, okay, if the forward momentum resulted in the pigeon moving at 2.85 meters per second, what was the height of the attack? So what we're looking at here is, for instance, I'll use a different color here. If we have, here's the pigeon, and then here's our red-tailed hawk that's moving in this direction after the attack, it maybe moves forward for about 2.85 meters per second, then starts moving downwards due to gravity. Okay? The reason that that's important is what would it mean if we needed to calculate the momentum upon striking the ground? What two things would we need to know to solve for momentum? The final velocity and the mass. But that is when it's moving that fast down here. We are given a speed not down here, but rather where? Up top here. So from what we see here, what can we presume about, and use your physics intuition, what's true about that variable? It's in the right spot, but it's just not quite labeled correctly, because that is an initial velocity. Okay? All right. So, what is the question ultimately asking for? What was the height? Okay? And we measure height in what? Could be a distance, could be meters, could be kilometers, could be centimeters. But what is a variable that we see that's similar to a distance? Say that again? Well, that's the variable, but the label, I should say. Not feet. We see that here. Someone said meters. Okay. So we need to find a place where, excuse me for a moment. Where do you see the variable d in any of your formulas? Where do you see the variable d in any of your formulas? Because we're looking for height, correct? Okay. But in order to do that, okay, you're telling me that, and that's correct. But if we put our initial velocity in here, that's not going to be able to answer this question, is it? Okay, because we want to know what this height is after that bird was attacked. Okay. So what is the variable that we're looking for? Height, and that would actually be d. Okay. So, do you want to work on that on your own to determine what that distance is?
Yes.
You want to work on it on your own? No? Okay. We will give you a couple of moments, a couple of minutes, I should say, and we will come back to this. All right. Is there another unknown that we need to put down here? Yes, a lot of you are saying final velocity. We need to calculate that as well. So, and I know how many of you feel that you are getting better at solving these problems? Okay, so keep those hands up. So if you are feeling a little uncomfortable maybe, look around. I see 4 hands up, 5 hands up, 6 hands up. You feel you're pretty good at solving these? All right. So if that is the case, if you feel that you are struggling, you put your hands down now. You certainly have someone that can help you with this. If you choose, it's a choice, to choose and come in and talk to myself. You can talk to those that had their arms up. You can certainly look for an upperclassman. And chances are, if you ask them, they will help you with this. Okay. So, what are we going to do next? Do we need to find, can we go straight into this portion or that formula? No. You're correct. Why not? We have to have the final velocity. So how are we going to solve for that final velocity? Maybe. How about we do what the formula tells us to do, right? So here is our equation. Where is the only place that you see final velocity besides momentum? In the acceleration formula. Do we have an acceleration? Yeah. So where does that go in our equation? Okay. What goes on the right side? Okay, and then what goes on the bottom? 4.35. Okay, we've got a fraction on the right side. We said we don't like dealing with fractions. Okay, so what is the best thing that you can do for probably right? So how many times do you suppose we've said this? 10 times, 11 times, 12 times? 17. Maybe this is about the 16th or 17th time. So hopefully, if we've said it 17 times, we know what to do next, which Are we changing that value? Okay. So, how are we going to get rid of this fraction? You said cross multiply, but you got to do it correctly. Okay, so if we cross multiply here, what does that give us in the parentheses? The same thing, which is VF minus what? Okay, so we cross multiplied here. What do we do with these two numbers? Okay, so once you cross multiply, what do we get with that? So 42.63. We can get rid of this because we don't need that anymore. Okay? Now, this is maybe the 6th, 7th, 8th, 9th, 10th time or whichever. What function are we doing between our variable and our number? What function is this? Subtraction. How do we undo subtraction? We're going to add. So what do we add to this side? So if we do it to the left side of the equation, what do we need to do over here? You need to add that as well. Okay? So 2.85, we're adding. Those cancel. So then VF equals what? 45.48. Okay, that's meters per second. Now, that's how fast that was moving once that pigeon hit the ground. So in this case, it's 45.48. But that's a velocity, not a distance. But now we can look at this guy right here because we just solved for this. Now, what's the last thing we're going to do? Okay. Back row. Are we on the bus here? Back row. Middle row. Middle row. Front row. Front row. Okay. Because one of the things, again, we're saying this, we're nodding our head yes, so what do we perceive that you do? You understand this, right? Okay. So what do we get for a height slash distance? Okay. So we don't need any of this anymore because we solved for that. Okay. So you had correctly said that 45.85 equals our unknown over 4.35. Okay. And if you like repetitive processes, which is fine, cross multiply. 1 times D gives you what? Just D. And then if we cross multiply here, what do we have to do here? You said you got 100 and meters. Okay. Is that what we got? So, again, are we feeling a little more comfortable with this? Because, again, it is your responsibility to ask questions. We go over the problems. We do that together. But if you don't understand, that's why we check for understanding, you've got to say something. And whose responsibility is that? Do we understand that it's your responsibility? We're all saying, well, majority of us are saying yes. Okay. We will continue with that arch video, and then we'll start to describe your project that we're going to try to get started tomorrow. Okay, so just pause this for just a moment. So now, as we continue to move forward tomorrow, okay, so the idea behind this is as follows. Okay. I had this. You have to have an upper design and a lower design. So I'll try to get this on camera. So if this was your upper design, this piece of wood here, and then of course your lower design down there, that's the same size, okay? Because remember yesterday we drew this rectangle. So this rectangle is what you see on this desk here, okay? We said maybe you would like to put one of your precast down here, so you set it on here, mark it. And then maybe you want another one up here, you mark that, and then the final one maybe up here and a little to the left. So what you can do is then bend these tongue depressors, because there has to be, these will go into the sterilizer, and we'll force that steam into it so you can actually bend this to maintain its shape. Because eventually, like I said, it's just going to go back to its original shape once you let go. So then once you have your precast made, you'll put them in there and then let them sit in that precast overnight. Yes?
Can we do this with our partner?
Yes. So look, try to get yourself into, we got 21, so if my math is correct, 21 divided by 3 gives you 7, right? Okay? So how can you ensure that the top portion of your precast will be right below the bottom one? What do you think you can do with 2 pieces of lumber to make sure when you drill this hole in here that they're exactly on top of one another? What would you do with them 2 pieces of wood maybe?
Drill them together.
You're going to drill them together. Well, you drill the holes and then take wood screws and put them together. So now you have 2 of these, okay? So here's your bottom one, then your top one, as you would guess, right on top of it. So you take a wood screw here and a wood screw on this side, and that will make sure that you have one on top of the other. Okay? Then you take a spade bit, which there's different ways of boring a hole out of lumber. You have Forstner bits, you have regular drill bits, but what we like to use is what's called a spade bit. Okay? So in this case, it's got 2 sharp edges to it. So as it's going down, it's boring a hole into the lumber that you're going to be putting in here. So you would drill all the way through according to the holes that you are going to design. Okay? We okay? Oh, okay. Is this overwhelming right now?
No.
Okay. I just thought I would check just to be sure. Okay. Now, not everyone will be using 1-inch dowels. We've got PVC tubing over there too, which works just the same. All right. So we have just a few minutes left. We'll go ahead and leave that time for yourself. Okay. We'll catch up to you next time.